In this next video, I would like to take you through a couple different patches. Now, Batzilla is so complex, creating a patch from scratch could take a very, very long time, depending on how complex it is. So I've picked a couple patches that we can reverse engineer a bit and take a listen and look at how some patches and different sections of the synth are used in context. First, let's take a look at a patch called CZ Style Bass. Now, this one is relatively simple. All four of the oscillators are being used as a typical oscillator. Let's take a listen to what each individual oscillator is doing. All right, here's oscillator 1 here. And it's panned hard left. And we're using the envelope generator number 2 to simply control the amount of phase distortion, moving it from a sawtooth back to the sine wave. Next, take a listen to oscillator number 2. So we have a higher pitched oscillator with the same effect, envelope number 2, controlling the phase distortion, moving it from a sawtooth waveform to a sine waveform. Next, we have oscillator number 3 doing something to the same effect. Envelope generator number 2 affecting the phase distortion, modulating it from a sawtooth wave again to a sine wave. Finally, let's take a listen to oscillator number 4. Now here we have a sawtooth waveform being sent into the filter section, and then the cutoff frequency of that filter being modulated by envelope number 3. So it's closing down this cutoff filter according to this envelope generator. And then we have envelope 1 controlling the output, this entire synth. And that's right here. With some panning, we get a very wide sounding bass. A very simple patch, but very effective. Let's move on to a kick drum type sound. I've picked out one called Acid Kick. Let's take a listen to what it's doing. If I hold down the key, we have it in time. Let's see what's going on. We have one oscillator being patched to the output, and the gate, or an on-off, is controlling the volume of that output. And then we have a couple different parameters in that oscillator being modulated. We have the pitch being modulated, and we can hear that drop in pitch, very standard with a drum machine type kick. If we remove that modulation, we don't have that drop or that kicky type sound. We also have some phase modulation and some phase distortion. Let's see what it sounds like when we take away that modulation. That's what's giving us the click type sound. And then the phase distortion is giving us some of that dirt. All right, so how are we accomplishing this modulation here? Well, it looks like everything is coming from the inverter, which is then in turn coming from map number 1. And that is the map generator number 1 here. If we play a note, we can see this map generator moving. Okay, so it's sweeping down. Now what's making this map generator sweep down? Well, it's the LFO number 1 triangle output. And that's sending this modulation to the inverter. So this actually could have been written in a positive way. Let's take a look at the LFO. This is what's controlling this mapping generator. It's movement down. So if we start moving or tweaking the LFO, we should change how this pitch is dropped, how the phase modulation and phase distortion are applied or modulated as well. There we go, changing the speed. We can also change the waveform itself. So right now with this wave all the way dropped down, we have a sawtooth type waveform. Let's change that and see what happens. So now you can see that LFO going up and down instead of just down. If we move this wave shape all the way up, we can have it go up instead of down. Okay. So that mapping generator is controlling this modulation and this modulation. And then we have a lag generator adding some lag to the pitch drop. Let's move the lag generator parameters around and see how that changes the sound. We can change the speed at which that LFO sweeps through these settings here, affecting the pitch. So maybe instead of a kick sound like this, we could get the Simmons type tom sound. Something like that.